everybody. I'm going to do a little lecture on grams, moles, Avogadro's number, how to convert them back and forth, and why I hate Avogadro's number. Hate's too strong a word. I don't hate it, but I don't use it that much, and I'll let you know why. So what I'm going to do is start off with an analogy, and you may or may not need this, but I like to do it because I think it helps make the concept clear. So we're all familiar with the word dozen. You know, you have a dozen eggs, and let's say I weighed eggs, and you found out that a carton of eggs weighs 2 pounds, and that you know, there's 12 eggs in a dozen, and so you know these, and when you think about it, this top one is measured, or it has to be, you know, given to you, and the second one you just kind of know. It's something that you're familiar with or that you've heard before. So if I asked you to do these conversions, like how many pounds of eggs does 6 dozen eggs weigh? You know, you can kind of just do that in your head and go, you know, 12. But if you want to write it out, you know, in like a cancellation form to kind of prove it, you can write some brackets down like that, and you can write a dozen eggs. And then you would use those terms up in the little given box, and you could say why 1 dozen eggs is 2 pounds eggs, and, you know, write all that out, and you get 12 pounds of eggs. Right? So that's pretty easy to do. No one has any problems with that. If I went and said, you know, 15 pounds of eggs, sorry, 15 pounds of eggs, yeah, well, how many dozen eggs is that? Well, you know, you could say 15 pounds, and you can put some brackets down. You'd look up to the top, you'd look at the blue, and you'd say there's 2 pounds of eggs, 1 dozen eggs. We don't even need to know how many's in a dozen, and, you know, 7.5 pounds. Sorry, 7.5 dozen. Now, obviously, you can have a half dozen eggs, no problem. If I carried that calculation on a little bit more, and I said, you know, how many eggs is that? Not how many dozen eggs, but how many eggs there are. And, right, makes sense in English. In green, I wrote dozen. In kind of orangey, I wrote eggs, but you can figure that out. So I would copy the same thing down, or I could just bring this number down from up above. And I could reach into my definition, and I could do this term, or do this expression. I could say there's 1 dozen is 12. If I wanted to write the word eggs, I could. And of course that equals 7.5 times 12, which I knew without checking a calculator is 90. 90 eggs. Great. So last question I'm going to do here is if I had 48 eggs, well, how much does that weigh? And you could kind of chain this calculation together. And you could say why there's 12 eggs is a dozen, and of course 1 dozen weighs 2 pounds, and so you get 8 pounds. So believe it or not, that's all the grams and moles calculations you really do in this class. And yet when we change the word dozen into this word mole, and we change the word pounds to grams, and instead of using 12, we use 6.0223 times 10 to the 23rd, a really big number. People can't figure things out. It seems so hard. Yeah. So anyway, what does the word mole mean? Mole is related to the word molar in Latin. It means to grind. So if you like take a mortar and pestle and finely grind things down, you get a mole. The teeth that do that in the back are molars. In like Oaxacan food, you know, they make mole. Mole is the same root word. The word molecule means thing that's been ground down, or small particle, something like that. So all those words are related, and this is bizarre, but the official abbreviation of mole is MOL. And if you think of all the time you're going to save not writing that E, I just wasted it. So, right on, so let's move on to these questions. So you can go back and forth between these two kind of pictures, but the green is the same as the green, and I kind of kept the color coding. So if I say 6 moles of C, now you could theoretically write out 6 moles of carbon atoms, but that's kind of tedious. Do brackets this time. I get that number 12, by the way, from the periodic table. And I'm just going to round off for this to make the numbers look nice. And obviously, that's 72. Right? So cancel, cancel. We're good. Now you could write C and C here, and that makes it look a little nicer. Right? That's number 1 calculation. Number 2 calculation that we do lots and lots of is the opposite. We say 24 grams of C is 12 grams per mole. So we're using the same tool up here, but upside down, and 2.0 moles of C. So why did they invent the mole? The mole is useful because when atoms react with each other, they don't react by weight, they react by how many there are. So we need to know if you're going to react and you happen to have half a mole of something, you will maybe need half a mole of the other thing to react with it, or maybe twice as much. You'll need 1 mole. But you can't just weigh things out and know that you have that many moles. You first have to calculate how many moles you need using molecular weights. So nature doesn't provide it. There's no such thing as a molometer. You have a balance to weigh things, or a beaker to carry a certain amount. Okay, so this next one, how many atoms are there in 24 grams of carbon? Now, first of all, before I do this, the number's always going to have to be a big number because atoms are really tiny. So if I said 24 grams and for some reason you end up with a number smaller than 1, usually means you flip the exponents in the wrong place. And that happens all the time, but be careful of that. Okay. So there's 12 grams per mole. And what does a mole mean? A mole is like the word dozen, except much bigger than 12. Okay, and out of that, you should get roughly 1.2 times 10 to the 24th atoms. Okay, and significant figures are a little off. Sorry, there we go. So you should get a lot of atoms, right? And the last question is, how much does 48 carbon atoms weigh? Obviously, the answer is going to be not a lot because atoms don't weigh very much, so you should get a very tiny number. So if I had 48 atoms, and there's 12 grams per mole, so what I can see is when I do it this way, I can say I'm canceling, and I'm canceling the number of atoms, and when I do all that, it kind of looks nice. Whoops. There we go. And I'm left with number of grams. And of course, in my head, without using a calculator, I know that it's 6.64 times 10 to the minus 24th. Great. So these two kinds of questions here at the bottom are really common. So every freshman chemistry book, every introductory book always includes Avogadro's number. This number here was named after a fellow who actually didn't discover it, but they just named it in his honor for something else. They wanted to honor him for some stuff. Named Avogadro, they named this number after him. And then, determining it's a whole interesting story if you like this kind of stuff. There's the whole history of how do you figure out Avogadro's number? We actually have a lab where we'll kind of try to figure this out. Einstein, one of his very first papers was all the different ways of measuring Avogadro's number. People have done a lot of different things, a lot of different ways. What comes as a surprise to people is that you never need to know it. And I had a conversation with some people once in a teaching conference about this, and they were like, well, of course you need to know it. And I said, really, why? They said, well, you just do. I said, well, when have you ever seen anyone use it? Never. And it turns out that if you go read any kind of chemistry journal, you never see, really anywhere, people doing calculations with like how many atoms are there in this sample. You know, it's almost you almost never see it. I'm not saying it's never done, but it's just not very common. All chemistry units are moles. Over and over and over again, you do any chemistry journal, all you see is moles. The reason we invented moles was to avoid trying to count huge numbers of atoms, and it just became unwieldy. So moles are great. We use moles all the time. 12 grams of carbon is like, a small pile of carbon. It makes sense. It's 1 mole. Half a mole of steel is a couple coins, easy to measure, easy to kind of relate to. Atoms, the numbers are just so astronomically huge, you just can't even wrap your head around them, so we just never use them. So really, doing atom conversions is fun, I guess, and it's a common thing in introductory classes, but it's not necessary. Okay, I got one last kind of dumb analogy, and I told you if you had a car with 4 doors, so you're given a formula of one car is 4 doors, and here's your formula. It's this little picture. If I told you you have 6 dozen cars, how many dozen doors do you have? 6, right? I mean, 6 times 4, obviously, right? So what you could do is you could say 6 dozen cars, and obviously one car is 4 doors, right? And that's kind of dumb and kind of silly. So you actually have 24 dozen doors. Now, okay, that's kind of dumb, and I get it. But we'll use that analogy in just a second. So here's the kind of typical questions you're going to see in really most textbooks, right? These are the big ones. There's going to be, okay, this last one's not, and this last one's not that important. You're going to be given a molecular weight or a formula or both. And so sometimes you'll see, here's a formula. This stuff's called carbon tetrachloride, CCl4. It's molecular weight, 153.8. If you're ever in a lab, usually somewhere up on the top is a label that'll say the molecular weight. It's almost on every single chemical bottle. But if you're in a lab, you see a bottle of chemical, check it out. You always see MW or FW. You'll see FW for formula weight sometimes. Here's a little cartoon of it. You got 4 green chlorines, black carbon. Okay, so first 2 questions. If I told you how many moles of carbon tetrachloride are there, how much does that weigh, right? You could say 0.50 moles, change that, of CCl4. You really should label everything. Not important now, but important later. This term, grams per mole, if you expand it, means this. Okay. Gram equals a mole of CCl4. So you can turn that into 1 mole on the bottom equals 76.9 grams. And so always try to include that little label. It looks nice. Especially later. If you're doing more complex calculations, it really pays off. Okay, the reverse of that. The molecular weight has to go on the bottom. And what I really hopefully won't see is don't do like, algebra. Don't try to do, oh, okay, so I'll just flip these around and, to do it that way and then plug it in. It's tempting, but there's a reason why. When you're going to daisy chain calculations together, like let's say you're going to go from grams to moles, moles of one thing to moles of another, back to grams, back to liquid density, like back to milliliters. You have 5 things in a row, 6 things in a row. Doing algebra 6 times is just tedious. You can, but if you can set it up in a stripe like I'm doing now, with 6 steps, it's going to be so much easier. Works really nicely. Okay, this last question messes people up a lot of times. It's how many moles of Cl. Actually, this is a good question. I misread it earlier. Never mind. It's not an Avogadro's question. How many moles of Cl atoms are in 10 grams of carbon tet? So I'm going to copy this question down. It's the same thing. But if you put it all in one, it would look something like this. And so what you've now figured out in this, in the previous question up there was sort of like how many cars there are. And now we're trying to figure out how many doors there are. So you have a formula that tells you that there's 1 CCl4 for every 4 chlorine atoms, or there's 4 chlorine atoms in CCl4. Right, that's comes from a formula. So a formula is a conversion factor. A formula is a tool. A molecular weight is a tool, right? So the tool, or the conversion factor, if you're, that's what most textbooks call it. Tools and conversion factors are the same things. We use them on a number. And remember, a conversion factor or a tool is always something equals something, or something slash something. Now, to make this look nice, I'm going to write the word mole and mole here. It's kind of optional, but I like the way it looks. So I come in and I'm going to cancel. Moles canceling moles. Grams cancels grams. I'm left with moles of Cl, and it looks pretty nice. So the answer here would be 0.260 moles of just Cl. Believe it or not, that's mostly it for grams and moles. It's this last set of calculations, it's actually pretty easy, and you just have to set it up and realize what tool am I using. So the number one mistake you can make, though, is, I'll show you this one. So this is going to be wrong, so we'll do it in, I don't know, do it in red. Okay, so this is the answer you're going to see a lot for this last question. And what did the person do? They said, God, I got 10 grams of carbon tetrachloride, and they want how many moles of Cl? Okay. They went in the periodic table, and they looked up chlorine, and they found that chlorine is 35.45, and it looks something like that. And so then they said, okay, I'll just put that in there and I'll convert. Well, it kind of looks like it would work, the way I've written it. But if you think about it, what is that 10 grams of? It's 10 grams of CCl4, and this is grams per mole of something else. So labeling, which I actually forgot to do up there, is really important, even in a question like this. Now, okay, so in the question, some of the questions, it's like if there's no other chemicals around, it's just one thing. You can kind of get away without labeling because you're not going to get that confused. But even on relatively simple questions like this, they're asking you to go from carbon tetrachloride to something else, another chemical. You'll need to use a formula like a 4-to-1 ratio. So if you try to cancel this out at first, you end up with all sorts of goofball numbers that just don't make any sense. And there's more complex ways of doing this question, but why bother? Don't do that. So, label, understand what the conversion factors are, and it's not going to be that bad. So, but it's a skill that is really important. This is a critical skill. Don't blow it off, because throughout your chemistry career, you're going to be doing lots and lots and lots of grams and moles. And there's a lot of things in this class we say, oh, this is really important. And we don't use it that much. This is definitely one of them. We use it the rest of the semester, all the calculation sections of this class. This is it over and over and over again. So I'll have another video that kind of goes into more complicated examples, but hopefully that helps for now.